You can use top to not get the full results of a query, but only the beginning. Or you can use the NZ equivalent fetch. In both cases, the optimizer will make sure to create an execution plan that is optimized for that a lower number of rows. That is done using Rowgoals, and in this video we will look at how exactly that works. Let's start with a demo, and in this demo I use an extra large version of the sales order header table in the AdventureWorks sample database. The normal AdventureWorks sample database has a sales order header table of about, I think about 30,000 rows, which is simply not realistic in modern times. I have created a much larger version of this with about 6 million rows. Even that is small in comparison to many of the tables that I have to encounter at my clients, but it's at least large enough to show some of the things at play. So let's look at this query where I simply get some data from that table. And you saw that there was a slight delay. We will do it again later so you can focus on it, but you may have noticed a slight delay before results started to appear. Now this query is still running. It takes some time, but for the record, most of the time that this took is the overhead in Management Studio to collect this data. If you look here, you will see that there is over 6 million rows of data returned to Management Studio. The whole query ran for 15 seconds, but most of that time was SQL Server waiting for Management Studio to catch up. And I'm not just saying that, you can see that in the execution plan. When I go to the statistics, I can go to the wait statistics, and here you see that there was 12 seconds spent waiting for async network I/O. That's the wait stat that says SQL Server is ready to produce rows, but the client, Management Studio in this case, isn't ready yet. So SQL Server was waiting. There was only 3 seconds actual execution time. And you can also see that here where, well, parallelism says 1.9, so there's perhaps some rounding at stake here, but the actual work was about 2 seconds. You also see here that the sort operator took 8 seconds, and the way sort works, it doesn't produce any output until it's done. So we had a delay of almost a second before the first results appeared. And if I run the query again, and now you focus on it, you should see it. I'm going to hit the execute, and you should see approximately a second delay before the query's results starts to appear. I'm hitting it now. And now the first results are there. And again, 2 more seconds to produce the results, and then 12 seconds to return everything. I'm going to cancel it because we already saw it. Now, a 1 second delay is in many cases not bad. But if this were not a 6 million row table, but a 600 million row table or a 6 billion row table, then that delay would be longer. And often the user isn't interested in all 6 million or 6 billion rows of results. They want to see the first page, the first 25 rows. Perhaps they will later hit page down for the next page, perhaps they won't, but we want that first page to be there fast. Now, of course, in T-SQL you can easily tell SQL Server that by saying, hey, I am going to add a top 25. And if I do this, and now I'm not going to execute it, I'm just going to look at the execution plan. What you see here is that the execution plan has completely changed. There is a top operator, which is of course needed to tell the rest of the execution plan after 25 rows were done. But the part where the actual data is produced is also different. If I go back to the execution plan of the original query without the top, you see that there is a clustered index scan that just reads the entire table, all 6 million rows, then it is all sorted, and then, because we're in parallel, everything is guarded on a single stream, so we can return the data. Now, with this top 25 added, we lose the parallelism. We also do a completely different approach. Now we scan a non-clustered index, and this is an index on the customer ID column. And it is scanned with the ordered property set to true. So we scan the data in the order of the customer ID, which is of course what we asked in the query. So it makes sense that we do that, and then in a nested loops we go into a key lookup because the index isn't covering. We need the due date, which is not in the index, and that's why we need a key lookup that will return the due date from the clustered index. Because we do this only 25 times, it's fast, it's cheap, and we don't have to sort anything. And the biggest benefit here is not only we don't need to sort stuff, it's also that because we have this new execution plan, now we get the results instantly. You see that there's not a 1 second wait. I can hit execute and the results are there. So here we see that because we added the top, the optimizer came up with a better execution plan. How does this work internally? Well, there are some things you can see in the execution plan that give you an idea that, hey, this is being used. The biggest giveaway is, of course, the top operator itself, which tells you, I only return the first 25 rows. Okay, that's fair. But how does it affect the rest? How did the optimizer decide on this execution plan and not the other execution plan? There are some things you can see here. So if I go to this nested loops, in the pop-up you see that the estimated number of rows is 25, which is of course because that's all we want. We only want the first 25 rows. We're not going for all 6 million. But there's an interesting thing in the full properties list, and I'll scroll down here and then highlight it. It's called, you can't see the full name now, it's called the estimate rows without rowgoal. So what SQL Server does, it first pretends that there is no rowgoal. It pretends you want everything, all 6.3 million rows. I'm rounding. That would result in 6.3 million rows returned by nested loops. It would also result in 6.3 million rows. Let's see, there we are. Now it shows the name and not the number. So it also shows 6.3 million rows from the index scan. But there is a rowgoal. So in reality, we return 6 rows here and we return 6 rows here as well. 25, I'm sorry, I get my examples mixed up. We'll have an example with 6 later. So that is how this works. And it always works like that if you have a top clause. So if I don't want the data ordered by customer ID but ordered by due date, then SQL Server will also come up with an execution plan that is optimized. But it's not as optimal. If I look at the execution plan here, I see, yeah, there is a top. And for instance, on the sort, you will see that the estimated number of rows is 25, but the estimated rows without rowgoal is once more 6.3 million. However, on the clustered index scan, the estimated number of rows is now 6.3 million and there is no estimated rows without rowgoal. The property is simply not here. The reason is there is no index that SQL Server can use to get the ordering by due date for free. So it needs a sort. And if you need a sort, you need to read all the data. So the sort still needs to read all the data. The rowgoal still had an effect. Instead of a regular sort, we now have a top N sort, which is also why the first results still appeared faster. There was a delay, but it was only about 130 milliseconds. So you probably didn't notice it, but it was there, and on a larger set once more, it would have been noticeable. So this is how a row goal works, how you can see it in an execution plan, and how it helps you get a better execution plan for those first 25 rows. So to wrap it up, SQL Server first does the cardinality estimation as if there is no row goal, as if you want everything. It computes it stores that in the estimated rows without row goal. Then it scales all the numbers down to reach the requested number of rows, and that is stored in the estimated number of rows per execution. And as you saw in the last example, if that is once more equal to the estimated rows without row goal, then the estimated rows without row goal is simply not shown, even though it might still have had an effect. In the next video, we will look at some other situations where a rowgoal might be put in a query that you might not expect. Bye bye.